Hello everyone. In this video we're going to be doing trapping rainwater, which is LeetCode problem number 42. So this problem has a 97.93 frequency, so it is asked a lot. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So example 1 here, input height. So 0, 1, 0, this is just all of the black bars. And the output is 6. So basically you can say that when there's a wall here and a wall here, and there's nothing here, you can add, that will capture rainwater. And so we have 1, 2, 3, 4, 5, 6 units of rainwater. And I'm not going to go through this second example, there's no graph. Alright, and this is actually labeled as a hard problem, so this one might take a while to get through, but hopefully you'll have a better understanding by the end of it. So I'm going to use the example 1. The left side, so we're going to have 5 variables here. We're going to have a left side, we're going to initialize that to 0, and the right side is going to be 11. So the size of the array is 12, but because of the zero-based indexing, the right side is 11. So these 2 pointers are going to start on the left and right. Then we're going to keep track of the max height on the left side as well as the max height on the right side. And then we'll pass back how much rainwater this solution can hold. Alright, so this is what the graph looks like. This is what they give us. So we're going to start with L equal to 0 and right equal to 11. So on this first pass, the left side height, 0, is greater than the right side, less than the right side height of 1. So what we're going to do is we're going to move the left pointer 1 to the right. So the left side becomes 1, and we need to calculate the max height on the right side, which is also 1. Alright, now the second pass, we're going to compare the left side height to the right side height. Now the left side height is equal to the right side height, so we're going to move the right number, or the right pointer, in 1. So we're going to decrement it by 1. And then we've got to calculate the max height on the left side. So now on the third pass, we've got left side 1 and right side is actually 2 now. So this height is less than the right side height. The left side height is less than right side height. So we're going to move the left pointer 1 to the right, making that 2. And we'll also calculate the max height on the right side will be 2. Alright, now the fourth pass is what I like to call the water stop. And I used to run marathons, and I would love water stops because I could stop running. I don't do marathons anymore. But anyway, so we have the left side is 2, the right side is 10, and we have max height of 1, 2. So let's take away all of the indexes that we haven't gone through yet. So if you do that, you end up with this graph. Now technically you have a wall here of 1 and a wall here of 2. So you could put water all the way across this. Now this isn't accurate because we have no idea what's in 3, 4, 5, 6, 7, 8, or 9. But we do know that in index 2 we're going to have 1 unit of water because the L2 is 0 and the wall height, the max height on the left side is 1 and the max height on the right side is 2. So we can capture 1 unit of water there. And so we'll tag that in the rainwater by adding 1 to it. So let's go through that. So we know that, we're on the fourth step now. So left side height is 0 and right side height is 2. And so we're going to add that water that we just talked about. And now I've got to increment the left side to 3 because 0 is less than 2. So we'll make the left side 3. Now we're going through the 5th pass. So the left side height 2 equals the right side height of 2. So now we've got to decrement the right side. So we'll move that down to 9. And we'll calculate the left max height of 2. All right, so now we're on the 6th path, which is another one of these water stops. Okay, so we have index 3, we have index 9. So we're going to take out everything in between. So we have a wall of 2 here, but we also have a wall of 2 here from the index 10. And so technically all of this could be filled with water. But because we're only on index 9 on the right, we know for sure that this contains water. So we can increase water by 2, rainwater by 2. All right, so let's go through this with the entire graph. So we add water there. The left side 2 is greater than the right side of 1. So we move the right side in 1. Decrement that to 8. And that's all we do. So now we're on to the 7th pass, where the left side height equals the right side height. And when they're equal, we decrement the right side. So that's what we're going to do. So that becomes 7. And I think that's it for the 7th pass. Okay. Now we're on to the 8th pass. So the left side height is less than the right side height of 3. So now we've got to move the left over 1 to make that 4. And now the right side height is 3. The max, anyway. Okay, so now we have 7 and 4. So the 9th pass, we have left side 4, right side 7. So we're going to take out this 6, because we don't know that yet. And technically all this could be filled with rainwater. But again, we only know what L of 4 is, index 4. So we have that and can add that to rainwater. Now the 9th pass, which is another water stop. Or actually, we're still on the 9th pass. So add 1 here for the water stop. Now the left side height is 1 and the right side height is 3. So this right side is winning. And so we need to move the left to 5, increase that to 5, and then we move on to the 10th pass. Now, here we've got another 0. And so we remove this block, just for demonstrative purposes anyway. And all this could be filled with water. But of course, we don't know what 6 is yet, so the only 2 blocks we can include are what L5 can hold. And so we increase the rainwater to 5. So now if we look at this for real, add 2 there, and then the left side height, which is 0, is less than the right side height of 3. So we move that over, make it 6, and now we're really just left with 1 more pass, which we see that left side height 1 is less than the right side height 3, but now if we move left or right any further, they're going to overlap. But we know that this last spot can hold water because L is 1 and the max height is 2. And we know that the height on the right is 3. And that is pretty much how this problem is going to play out. Oh yeah, we increment rainwater to 6, and that's the answer that they're looking for. So how do we code this? Okay, the first thing we do is look at the method that they give us. So public int trap and an int array of height. So they're expecting an int result and passing in an array of different heights. So we're going to define those first five variables that we talked about. The result, which is what's going to be passed back. The left, the right is height dot length minus 1. Left max is 0, and right max initializes to 0. All right, so while left is less than right, so these are the arrows at the bottom of my demonstration. So if the height left is less than the height right, As we saw in the example, the initial value of left was 0 and the initial value of right was 1. So if height left is greater than or equal to left max, then we're just going to assign left max equal to that height left. Otherwise, we're going to add to the result. So left max minus the height of left. So because we already know that this height left is less than the height right, so it means we have a wall over here right that's bigger than anything we have on the left. So that's why we can take the max left minus whatever the height of the current height of the value of left, and that will be a spot for capturing rain. And that is pretty much it for when the height is less than, the height on the left is less than right. We need to when we increment the left at the end. Okay, so now we're going to do the same thing with the right. So if the height left is greater than or equal to the height right, and then the height right is greater than or equal to right max, we're going to take care of the maximum height first. We're going to assign this right max equal to the height on the right. Else, we're going to add the result plus equals right max minus the height. Again, this is the same thing that we saw on the left. Because the left is already greater than the right, we've got this wall on the left that's never going to exceed, or nothing we do on the right here is going to end up going over the top of the left. And we end that, and we decrement right. And in the method, and we return the result, and that's it. All right, let's see how to do this in the debugger. So I use the example. Example 1. Okay, so we're going to initialize all these variables. Right becomes 11, left max, and right max is 0. So while left is less than right. So the height left is 0, and the height right is 1. So left is less than 1. And if the height left of 0 is greater than or equal to left max, which it is, it's the same, it's equal to it, so we're just going to assign left. So basically this assigns 0 to 0, but it keeps us from adding it to the result. And then we increment right, so right is now 1. So left is less than right, which it is. If height left is less than left right, if height left is less than height right, which it isn't because height left is 1 and height right is 1. So now we're going to go into the right side. And right max equals height right, which is actually 1. And so the right max over here is 1. And we're going to return, we're going to end this else statement by decrementing the right side. So this is pretty much, we're just going to go through this until left is not less than right. So here we have 1 and the right is 2, so we're going to go into the left side. And left is greater than or equal to left max, which is actually greater because it's 1, so now left max is equal to 1, and we increment left by 1. So we've got 2 and 10. So the height left is 0, and the height right was 2. So here we've got, this is not, so this is, okay, this is the first time we've got the height left is 0, and the max is, what is it? Here we go. Okay, so left max is 1, and the height is 0. So we've got a spot where we can attach rain, or where rainwater can collect, because we know that the right is larger than anything we do on the left. So result is now equal to 1. We've got it up here, result is 1. All right, so we've got 3 and 10. Left is 2, right is 2, so left equals right. Right max is 1, so that is not greater than the right max, which is 2, so we decrement the right. Okay, so now we've got left is 2, right is 1, so it's not less than, so we're going to go back to height right. Height right is not greater than the right max, so the right max is 2, and the height of right is 1. So now we're going to add 1 to the result and decrement the right. So I've got 3 and 8. Height left is 2, height right is 2. So it's not less than. The right max equals, oh yeah, okay, the height right, greater, okay, yeah, so the height right is, index 8 is 2, and the right max is, no wait, I'm sorry, yeah, it's equal to, so basically the right max is also 2, so we'll bypass, or we add the, what are we doing? Oh yeah, we add it to the result. Okay, so we added the result, 2 minus 1 to add that to the result. All right, so now we're at 3 and 7. And let's see here. What do we got? 2 and 3. So 2 is less than 3. Left max. Increase left by 1. Now we're 4 and 7. Height of 1 and 3. Left max. Is greater than or equal to left max? No. So here we've got another one of the cases where left max is 2 and the height at left is 1. So we're going to add 1 to the result and decrement or increase left. All right, almost through this. I know this video is getting long. Okay, so here we have height left is 0, height right is 3, height left. Okay, yeah, so because we have left is greater than the left max, so the height, let's see, height left is greater than or equal to left max. So we need to add 1 to the result because the result left max is 2 and the height is 0. So there's where we add the 2. If you remember from the example, we had one case where we added 2 blocks to the raindrops. And then finally we have left is 0, right is 3, and the height left is 1, and left max is 2. So it's not greater than or equal, so we need to add 1 more to the height and increase left. So now left is not greater than, or less than right, and the result is 6, and that is what we see. All right, so let's run this through LeetCode quick, see what we get. And it is accepted, and then we'll submit this. Oops, it looks like, yeah, so it's faster than 100% and 38 megabytes, which is less than 47%. So the last thing we'll do is go through the space and time complexity. So time complexity is O of n. Basically, as you increase the input parameter, we're going to have to, it increases the number of times we have to go through the while loop, so it takes longer. But space complexity is O of 1. All we're doing is basically adding and dropping, or decrementing and incrementing the pointers and adding stuff to the results. So, and the max for left and right. So there really is no extra space needed. And that's it. So sorry this video took so long. It is a hard problem, so needs a little more explaining. Good luck if you actually get this problem. And let me know if you have questions, and we'll see you next time. Thank you.